This video is on key features of a function, number 4, with context. The physics class is doing experiments with model rockets. They place an electronic chip inside the rocket that records the height after it has been launched into the air. The data from the chip is displayed in the graph below. So we have a graph here where the x-axis is the seconds and the y-axis is the height in feet. So our seconds is our independent variable and our dependent is the height, because the height of the rocket depends on how long it's been since it was launched. So it says the first question is estimate the height after 5 seconds. That means that we're looking at the 5 seconds. So at the 5 seconds right here, I'm just going to draw up real quick until I get to the function. And I run into approximately, going over to the y-axis, the 80. So that would be 80 feet. So I will write out 80 feet is approximately our answer. Always put your units with your answers. Now it says estimate the height after 2.5 seconds. So that's 2.5 seconds. So we're going to go to the 2 and the 3. So we're going to go in between the 2 and the 3. We're going to go halfway between the 2 and the 3. And we're going to see approximately, because it won't be perfect, when this blue graph crosses the actual function, the actual graph. It's about here, and if I go over to the left, we get to about 140 feet. So my answer, I'm going to say approximately 140 feet. And it does say to estimate, so that means that we know it won't be 100% perfect. So we have 140 feet. The next question says, when will the height be approximately 40 feet in the air? And then it says, why are there two answers? So we know that there's going to be two answers. So we're going to use a green highlighter for this. I want to go to the 40 feet in the air. That means it's the height of 40 feet. So I'm going to go to the height of 40 feet, which is this number right here. I'm going to go across the graph, and I see it cross one time, and then it crossed again. So that's 40 feet in the air happened twice. So there are two answers. So what are those two answers? And it's approximately. So we have one at about a half of a second. So approximately 0.5. And the other one looks to be at about 5.5 seconds. Always label your answers. So why are there two answers? Well, again, this goes back to context. We are using a model rocket. So a rocket will go up, come to its maximum, but then it will come back down. So it started on the ground and it went up and hit the 40 feet at a half a second, and it kept going up and up and up, and then it comes back down, and then it has to come back through the 40 feet to get back down to the ground. So this happens twice. This happens twice because the rocket goes up and then has to come back down. And again, the height is dependent on the time that it took. Why was there only one height at 5 seconds? Because there's only one time it hits 5 seconds. 5 seconds doesn't happen multiple times. The height, however, depends on the function, on the context, and on the independent variable. So because this context was a parabola that goes up and then back down, we have to account for the going up part, the increasing, and then the decreasing location where it hit that 40 feet. Question D says find the maximum coordinate and value. So the coordinate is the actual coordinate. The value is the y value of the function, or of the maximum. So the maximum is going to be the highest point on the graph. So maximum is a coordinate. If we go to the graph, this is the highest point on the graph. The x value is at 3, and the y value looks to be about 145. So 3, 145. And the value will be the 145. Now that's the y, so it's in feet. So it'll be, the value is 145 feet. It does say to explain the meaning in context. So of the maximum, the 3 was the seconds, and the maximum height was 145 feet. That means that the highest point that the rocket reaches is 145 feet, but it takes 3 seconds to get there. So to explain the meaning, it would be the highest point the rocket reaches is 145 feet after 3 seconds. That means from 0 to 3 seconds it is increasing, and then after 3 seconds it is decreasing until it hits the ground. And we can see that it goes up into the air and down the same length of time. So it goes up for 3 seconds and then it comes back down for 3 seconds. And that is symmetry. The next question says find the y-intercept and interpret the meaning of this in context of the problem. So the y-intercept again is where the graph crosses the y-axis, or when the x value is 0. So if we come to the y-axis, we can see the function is hitting at this location, which is the origin, which is at 0, 0. So the y-intercept is 0, 0. So what does this mean in the context? So at 0 seconds, the rocket is at 0 feet in the air. That means that the rocket should be starting on the ground. So we can say that the rocket starts on the ground. And we know that because that is at 0 feet. The next question says find the x-intercept or septs, meaning there could be multiple, and interpret the meaning of these in context. So the x-intercepts are when the y value is 0 or when it crosses the x-axis. So coming up to our graph, we have the x-axis is here, and it crosses, or it touches at one location and then at a second location. There are 2 locations where it hits the x-axis. Those 2 locations are also at 0, 0. But it's also at 6, 0. So again, the x-intercept is when the y value is 0. So the 0, 0, 6, 0. Those are your 2 x-intercepts. So interpret the meaning. So this one, the rocket, is interpreting the x-intercept, meaning the rocket is hitting the ground, because that's the y value of 0. Basically, it's asking, when is the rocket touching the ground? So we know that the rocket is on the ground at the beginning, because that's where it started from, but it also hits at 6 seconds as well. So we're going to write that. The rocket is on the ground, because that's what x-intercepts are talking about in this context, at 2 times, at 0 seconds and 6 seconds. So what that also means, because it's a rocket, it went up and then came back down, is that it took from 0 to 6 seconds for the rocket to go up and then come back down. So from 0 to 6 is 6 seconds. So I'm going to make a note. It took 6 seconds for the rocket to land. Now we did not go before or underneath the x-axis, because that would be underneath the ground, and we also didn't go to the left of the y-axis, because then that would be negative seconds. So we know that in this context we can only use the first quadrant, which will help us when we describe the domain of the function. Remember that the domain is the x value, so in this case it's the seconds of the rocket. Now with the domain, we're using the x's, which are the seconds. We know that the first second that it hits is at 0 seconds, because we know that we can't go before 0 seconds, and we know we can be at 0 seconds. We also know that the rocket landed at 6 seconds. So that would be the largest x value, because we know that it's not going to keep being in the air past it landing. So we know that the first number would be 0, the last number would be 6. We know that our rocket is in the air between 0 and 6 seconds. So we know it's going to be 0 is going to be the smallest, so it's smaller than x, but it can be at 0 seconds, as in the rocket has not launched yet. So we're going to put the at, so less than or equal to. Then x is also going to be, so your seconds are going to be smaller than 6, so x is less than 6, but it will hit at 6. So that means that it's landing at 6 seconds, so we can put the equal to symbol. So our domain is 0 is less than or equal to x, less than or equal to 6. Describe the range of the function. The range was the height in feet. So we know that this is also your y values. The range was the height. So what is the smallest height that the rocket could have? Well, the rocket we know will be on the ground, and it's not going to go below the ground. So the height could be at 0 feet, because we know that is the smallest feet that the rocket could be at. But then what was the highest location that the rocket went? And that came from our maximum. Find the maximum and value. That's why we find the maximum value. So our value is at 145 feet. So we would say that our largest feet would be 145. So we know that our rocket is between the heights of 0, the ground, and it goes up to 145 feet, and then it comes back down. So we know that 0 is going to be your smallest, so it's going to be less than. It'll be equal to as well, because it will hit the ground. And then y is going to be smaller than 145, but it will actually hit that 145, because that's the maximum height. So it'll be y is less than or equal to 145. And that would be our range. 0 is less than or equal to y, which is less than or equal to 145. Okay, and our last question says, find the interval of the domain over which the height of the rocket is increasing and also decreasing. So again, we're going to be looking at the domain. So we know that our domain is from 0 to 6. Those are our two numbers. So we know that our increasing decreasing has to start with a 0 and it has to end with the 6. So we want to look at our graph and understand what's happening here. So we can see that from the starting point, our first point from when it's on the ground, our rocket goes up and then it comes back down. So we already know that that is the context of a rocket. It will go up and then it will come back down. We need to know how long it goes up into the air for, and then how long it's coming back down for. And that was why we had our coordinate of our maximum, the symmetry. So we can look at the graph and see that the rocket increases, so it starts off going up into the air for 3 seconds. Then it turns to come down for 3 seconds. And then that is where it lands. So if we take that information and we can put that into our increasing, decreasing, since the graph actually increases first, we're going to use the increasing one first. I know that it's the domain, so I'm going to have to use my x's. It is going to start and stop because it does turn. It started at the amount of 0 seconds, so my 0 will go for my increasing. And then it went up for 3 seconds, so I know that it turned at 3 seconds, so my highest value for increasing is at the 3. I know it's in between these two numbers, so I know 0 is going to be less than x. It's not at 0 because it's not increasing yet. When it's starting, it hasn't moved yet. Then I know that x is going to be smaller than 3, not at, because the 3 is the turning point, and it's more kind of stationary at that point. That means it's not increasing or decreasing. Okay? So then it starts to decrease. So again, it's my domain, so I'm going to put my x's. Now, when does it start decreasing? It turned at the 3 seconds, so that is actually when it decreases. So it starts decreasing at the 3 seconds, and that makes sense that these two numbers match, because that's the turning point. Then it went for 3 more seconds, and it landed at 6 seconds. So I'm going to put the 6 at my last number. So I know it's decreasing from 3 until 6. So 3 is less than x, which is less than 6. They are not equal to, because at those locations, at the turning point, it is not going up or down, it is turning at that location. And at 6, it has landed, so it's not increasing or decreasing. So again, our increasing, decreasing can be seen from the graph itself, but it can also be understood from the scenario. If we think about what a rocket does, it goes up and then it comes back down. We just have to know where the turning point was, which is why we found the maximum coordinate.